Hello friends, welcome to my YouTube channel 12 School Zone. This video is related to engineering, and in this video we are going to learn about material science. In that we are going to learn about the topic Brinell hardness test. Brinell hardness test is a macro hardness test. A macro hardness test is nothing but the load applied is larger than 1 kg. I repeat, in macro hardness test the load applied is greater than 1 kg, and we use the Brinell hardness test to determine the hardness of metallic materials. We use the Brinell hardness test to determine the hardness of metallic materials. Now let's see the principle of Brinell hardness test. The principle is so simple. We'll see that now. Now let's see the principle of Brinell hardness test. In Brinell hardness test, we take a specimen and we place an indenter on the specimen. An indenter is nothing but a hardened steel ball of diameter d. I repeat, in Brinell hardness test, we take a specimen and we place an indenter on the specimen. An indenter is nothing but a hardened steel ball of diameter d. When we apply load on the indenter, it creates an indentation or impression on the specimen. The diameter of the indentation is represented by the letter small d, and the diameter of the indenter is given by the alphabet capital D. Then we will find the Brinell hardness number. The Brinell hardness number is given by applied load in kg divided by the area of impression. We can denote the applied load in kg using the letter P, and we denote the area of impression of steel ball using the letter A. So we can write the Brinell hardness number as P divided by A. Now we will derive an expression. Here we get 2p divided by pi d into capital D minus square root of capital D square minus small d square. Now we will see how we get this 2 in the numerator. Actually, the formula is written as P, that is the load, divided by area. Here we get P divided by pi d by 2 into d minus square root of d square minus d square. So when we take this 2 to the numerator, we get the formula as 2p divided by pi d into d minus square root of d square minus d square. Here, as I told already, p is the load applied, d is the diameter of steel ball in millimeter, and small d is the diameter of indentation. That is, indentation is the impression measured with the microscope. Hope you understood till principle. Now we'll see the construction of the Brinell hardness testing machine. The Brinell hardness testing machine consists of the following parts: a plunger, ball, specimen, anvil, hand wheel and a screw. Here the steel ball is attached to the plunger and the specimen is kept on the anvil. Now we will see the testing procedure. We place the test sample on top of the test table. And then the hardened steel ball is pressed onto the surface of the test sample. Then we press the hardened steel ball onto the test sample so that the load is applied and an indentation is created. Then the steel ball moves to the position of the sample and makes an impression or indentation. When we apply load, the steel ball moves and it makes an impression or indentation on the sample. Then the diameter of the impression can be found using a microscope. Then using the relation which we derived previously, that is the Brinell hardness number, we can determine the value of hardness. I repeat, the test sample is placed on top of the test table. Then we keep the hardened steel ball and press on the surface of the test sample. As the load is applied, the indentation is created on the sample and the diameter of the indentation is measured with the help of a microscope. Then using the relation we obtain the values. And before performing this test, we have certain precautions. The surface of the test sample should be clean. It should be free from dust or grease. The surface of the test sample should be clean and it should be free from grease or dust, as if the surface is slippery, the sample may fall down. We should make sure that the sample should be kept on a clean surface. Then the second precaution is that the test should not be made on thin specimen. As we apply the load, when very thin specimen is placed, the specimen may break due to the application of load. The third precaution is that the load should be applied gradually for 15 to 30 seconds only. the load should be applied gradually for 15 to 30 seconds only. We should not apply a heavy load, then it will lead to breakage or fracture of the material. Now we will see the advantages of this test. As I told, we have the precautions here. Now we will see the advantages. It is more useful for measuring the hardness of heterogeneous materials. We can use this method to find the hardness of heterogeneous materials, and the cost of testing is low as we use a steel indenter, and there is no requirement of a skilled operator as it is a simple mechanism. Any person can operate this and a skilled operator is not required. This method can also used for testing of soft materials. We can use this method even for testing of soft materials. It is also suitable for measuring hardness of porous powder. We can use this method for soft metals, porous powder and so on. So it has many advantages. Now we will see about the disadvantages and limitations. The test equipment is very heavy. So we cannot perform this test inside our home. We need a laboratory to perform this. The area of indentation created is so large, so it affects the surface quality. As we saw previously, the area of indentation is large, so it affects the surface quality. Then when we apply a hard material, when we apply the load on a hard material, the ball gets flattened on that hard surface. I repeat, when we perform this test for a hard material, the ball may get flattened on the hard surface. Then we will see the next disadvantage. The indentation diameter cannot be measured accurately. We can only measure the indentation approximately and not accurately. The last disadvantage is that it is a time consuming test. Now we will see the applications. This test is used for grey cast iron, copper and alloy. We can use this test for grey cast iron, copper and its alloy, and it can also be used for aluminium and its alloys and porous powder parts, as I mentioned already. Hope you understood this, friends. If you like this video, please share with your friends and don't forget to subscribe to my channel. Thank you, friends.